Okay, welcome back. More examples of factoring, solving equations by factoring. Now, in this case, we've got sort of an interesting one. We only have two terms, and we're going to solve by factoring. Well, 2x squared minus 50 is equal to 0. 2x squared, that doesn't look very promising, but we know that if we had the problem before where we had to factor a binomial, where we had to factor a trinomial, pardon me, or a binomial, and we noticed that there were two terms, we looked to see if it was either a difference of two squares or a difference of two cubes. In this case, cubes doesn't look very likely, but both terms are divisible by 2. And if we factor out 2, we're going to get x squared minus 25. And we think to ourselves, aha, 25 is a perfect square. And so I know that this will be the same thing as saying 2 times, since it's a difference of two squares, x minus the square root of 25, that's 5, times x plus the square root of 25. So we know that this is our factorization, and therefore our equation will be equal to saying 2 times x minus 5 times x plus 5 will equal 0. And now what we're going to do is we're going to take each factor and set it equal to 0. Well, of course, 2 does not equal to 0, so we don't have to worry about that particular factor. It's okay. 2 doesn't have to equal 0. As long as the other two factors can equal 0, we're good to go. And so x minus 5, if we set that guy equal to 0, well, yeah, sure enough, that's going to be true when x is equal to 2. And if we take our last factor, x plus 5, and set it equal to 0, we see that that's true when x is, that should be a 5 right here. Good Lord, what's the matter with me? X should equal negative 5 right here. And so our two solutions are going to be x equals 5 and x equals negative 5. Let's see if I can write that 5 a little bit more believably. There we go. Okay, and this is a good place to check because the factoring was a little bit more complex in this case. So let's see if we've worked it out. Go to the original equation. 2 times 5 squared minus 50 should equal 0 if we're correct. Well, of course, 5 squared is 25, and 2 times 25 is 50. And so, yes, that works. And so does negative 5, because 2 times negative 5 squared, we know that anytime we take a negative number and square it, we're going to get a positive number. Negative 5 squared is equal to positive 25, so it's 2 times 25 minus 50 once again, and we recognize 50 again, and we recognize that's the same thing. So yes, both of these work, and that's our solution set. All right, let's try this one. X plus 3 times x minus 5 is equal to 9. Well, this one's a little bit more complicated. First of all, yes, we could set the equation equal to 0 by subtracting 9 from both sides, but we still have the problem of this factored x plus 3 times x minus 5. So what we're going to have to do in order to actually go through the factorization right here is to carry out this multiplication of x plus 3 times x minus 5. Since it wasn't equal to 0 in the first place, it's really a necessity. So by our FOIL method, we could factor x times x to give us x squared, outer terms minus 5x, inner terms plus 3x, last terms minus 15. Minus 9 is equal to 0, and then we should simplify. So we get x squared minus 2x minus, let's see, 15 and 9, that would be 24. Okay, so this looks a little bit simpler right here. What could we do on the left? Well, we're going to need to find two factors. whose product is such that the leading term is x squared. We do that when we have x and x in each of those factors. And then, of course, we need two factors of negative 24 whose sum is negative 2. We know that negative 6 and positive 4 would fit that bill. So that's what we're going to fill in with our polynomial factors here. Then we set each factor equal to 0. X minus 6 is equal to 0. Of course, when x is equal to 6, and x plus 4 is equal to 0 when x is equal to negative 4. So now we should go through and make sure we check our solution. So I'll go ahead and make that habit of doing it right now. Into the original equation, I should substitute in with x equals 6. So 6 plus 3 times 6 minus 5. Does that equal 9? Well, the answer is yes, because that's 9 times 1. And yes, that's equal to 9. Pretty good. All right, let's try the other one. Negative 4. With negative 4 plus 3 times negative 4 minus 5 give us positive 9. Let's take a look here. Negative 4 plus 3, we know that's negative 1. Negative 4 minus negative 4 minus 5 is negative 9. And yes, there it is. Negative 1 times negative 9 is indeed positive 9. So both answers work. More stuff in the next video.